Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, step 2, step 3, and your challenge is to predict the number of colored squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of colored squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so we've got different patterns of colored squares here. And I guess the first question I have is, it looks like we're filling in this bigger gridded square area. And it looks like we start with a pink square and add some red squares. Does this mean this is quadratic because it seems to be about squares, or not quadratic? What do you think just by looking at it? Well, sometimes it can be hard to tell just by looking at it. So I think what I'm going to do is start with an analysis of the numbers and see what we're doing in each step. So I'll make a chart with the step number and the number of colored in squares in each step. So we've got 4 pink ones here in step 1. And then added to that 4 pink one, there's 4 more and 4 more and 2 more. So that is 10. So in step 2, we've got 14. That looks like it's growing pretty rapidly to start with. Let's see what happens in step 3. It looks like we're just adding the blue ones. The rest of it is the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 14 would be 24. So we're already up to 24. But look what's happening here. If we take the difference between each step, 14 minus 4 is 10, and 24 minus 14 is 10. We're just adding 10 every time. So I think the next step, we would add 10 again. So for step 4, we'd have 34. Guess we'd have to have a bigger square or another square to start filling in because there's only one open spot left there, but we should have 34 colored squares in step 4. When you get this constant in the differences, when it's changing by the same amount in every step, that is a linear pattern. And that means we can use the equation for a line to model it. So y equals mx plus b is our equation for the line. And this m, the slope, is the rate of change, so this difference between each step. So we're going to start with y equals 10x, and x represents the step number. And then to figure out what this b is, we have to go back to step 1 and try it out. So in step 1, you'd put in a 1 for the x. So that would mean y equals 10 times 1. And 10 times 1 is 10, but we only have 4. So that's 6 too many, so I've got to take 6 away. So we subtract 6. So our b is actually a negative 6. And that is our equation. You might want to test it, see if it works in other steps. So 10 times step 2 minus 6, that'd be 12 minus 6. Sorry, 20 minus 6, which is 14. That's what we've got there. And in step 3, 10 times 3 minus 6, that would be 30 minus 6 is 24. Yep, that's what we've got there. So this equation looks good. Y equals 10x minus 6. And then to calculate the number in step 43, we're just going to plug 43 in for x. So y equals 10 times 43 minus 6. And 10 times 43 is 430. So 430 minus 6 is 424 squares. So how did that go for you? Did you think that was going to be quadratic, or could you see that it was probably going to be linear? Let me know. Thanks, everybody.